Hello everybody, I'm Adam. For the given equation of the conic, which we have is 5x squared minus 6xy plus 5y squared minus 12 equals 0, we're going to rotate the axis and eliminate the xy term to get the equation in terms of x prime, y prime. Then we're going to find the equation in standard form and then sketch the graph of the equation. Now we have some given equations that are useful to us that we'll use. So we have the standard form of a conic as ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, c, d, e, and f are constants. And we also have the relationship between the angle of rotation and some of these coefficients as the cotangent of 2 theta equals a minus c over b. Now that's where we'll go ahead and start. We'll find the angle of rotation that we would have. Now, we can do this by using these first two equations that we mentioned. So what we have is that our cotangent, say of 2 theta, is equal to, as we see, a minus c over b. Well, our a, the coefficient in front of x squared, is 5, and our c, the coefficient in front of y squared, is 5. So we have 5 minus 5, and b, coefficient in front of our xy term, is negative 6. So we have 5 minus 5, which is 0 in the numerator, which just means this whole thing is going to be equal to 0. So when is cotangent of 2 theta equal to 0? Well, that's true whenever, say, our 2 theta is equal to, say, pi over 2. Well, just solving 2 theta equal to pi over 2, right, dividing through or multiplying both sides by a half, we get that theta is equal to, say, pi over 4. So what this implies is that the xy plane is going to be rotated by an angle of pi over 4. And looking at our graph over here, we've already sketched the x prime, y prime plane, rotated this angle of theta equal to pi over 4. Now we can continue and eliminate the xy term, but once we get our equation in x prime, y prime, this is where we're going to sketch the equation of. Okay, now let's go back and take a look at trying to eliminate the eliminate the xy term. So what we have is our two equations here. X is equal to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus y prime cosine theta. And that's what we're going to use here. So x is equal to, say, x prime times cosine of theta, and we know theta is pi over 4, so cosine at pi over 4 is, say, 1 over the square root of 2. And minus y prime times sine of theta, well, sine at pi over 4 is also 1 over the square root of 2. And we can just simplify this while we're here. Seeing that we have a common denominator of square root of 2, this can be written, say, as x prime minus y prime in our numerator, all divided by square root of 2. And also for y, so again, we have y equals x prime times sine of theta. Well, sine of theta, or pi over 4, again, is 1 over the square root of 2 plus y prime times cosine theta, which again is 1 over the square root of 2. And we can simplify this, having a common denominator. All right, so this will be x prime plus y prime, all divided by the square root of 2. Now, what can we do with these two things? Well, looking at both of these, we're going to plug these into our original equation up there, which will eliminate the xy term, and then simplify from there and try to write the equation in standard form. So, okay. So, plugging in both of these in for x and y in our original equation, so we're going to have 5 times x squared, or 5 times x prime minus y prime over the square root of 2, quantity squared, minus 6xy, or minus 6 times x, which is, again, x prime minus y prime over the square root of 2 times y, which is x prime plus y prime over the square root of 2, then plus 5y squared, and y, right, is x prime plus y prime over the square root of 2 squared, and we have minus 12 is equal to 0. Okay, so from this we're just going to simplify it and do some algebra. So take it from the left, squaring this term. If we square the bottom, we're going to get 2. So we'll write this, or take that 2 to the outside and write this as 5 halves times the quantity. Now squaring our top, we'll get, say, x prime squared minus 2 x prime y prime and plus quantity y prime squared. Okay, and moving our way over, so minus, now multiplying these two terms, the square root of 2 times square root of 2 would give us 2, and 6 over 2, right, would be 3. And so just foiling out the top, we're noticing this is a difference of signs, so it would give us a difference of squares, saving ourselves a little bit of time. So multiplying those out, we'd have x prime squared minus y prime squared. And lastly on this part, squaring the bottom gets us a 2, so we'd have plus, say, 5 halves times the quantity, squaring the top, we have x prime squared plus 2 x prime y prime plus y prime squared, and our term on the end, minus 12, which is equal to 0. Okay, so we've multiplied everything out. Now let's combine like terms if we can. So let's see what we have. Well, let's start with the x prime squared terms. So we have an x prime squared, so multiplying with 5 halves x prime squared. Going to the end, we have another 5 halves x prime squared. Adding both of those together, we get 5x prime squared, and then minus 3x prime squared. That's going to give us 5 minus 3, or 2, say, x prime squared. Okay, so we're done with our x prime squared terms. Moving our way along, we have minus 2 x prime y prime, so times 5 halves will give us a minus 5 x prime y prime. No x prime y prime term in the middle, but on the end we have a positive 2 x prime y prime. Multiplying with our 5 halves there, we have positive 5 x prime y prime. So actually the negative and the positive here would just cancel with each other. So there's really nothing to add with these. All right, now lastly we have our y prime squared. So multiplied with 5 halves, we have 5 halves y prime squared. Looking in the middle, negative 3 times negative, we have a positive 3 y prime squared, and then plus 5 halves y prime squared. So 5 halves plus 5 halves plus 3, looks like that's going to give us 8, say, y prime squared. And lastly, our negative 12, we're going to add that to the other side. So we'll have 2x prime squared plus 8y prime squared is equal to 12. Okay, we're almost there. Now we want to get this in standard form, and we see we kind of have the makings of something that might look like an ellipse. But with an ellipse, we want to have the right-hand side equal to 1. So getting this equal to 1, right, we're going to divide both sides by 12. So that gives us a 1 on our right-hand side. And we want to get the, say, y prime squared and x prime squared by itself. So we can rewrite this. Instead of 8 times y prime squared over 12, we can put the 8 on the bottom as 12 over 8. And the same thing with our 2. Right, this is 12 over 2. Okay, so let's clean this up one more time. So what are we going to have? So we're going to have x prime squared divided by 12 over 2, which is 6, plus, say, y prime squared over 12 over 8, which is 3 halves, and that's equal to 1. So there we have what looks like, as we said, the standard form of the equation of an ellipse. Now to help us sketch this, we need to find our a and our b. So we see the larger number is underneath the x, So that implies our a squared is equal to 6, or that a is equal to the square root of 6, and our b is equal to the square root of 3/2. To make these in a more usable form, let's find the decimal approximations. Okay, so taking our calculator and just finding what the square root of 6 is. So the square root of 6 is approximately, say, 2.4, and the square root of 3/2 is approximately, say, 1.2. Now we can use this to sketch our ellipse on our axes up here. Okay, so putting this all together, the a is underneath the x prime, so our major axis is going to go along the x prime axis, and our minor axis would be on the y prime axis. So a, being the distance from the center out to the vertices, our center at the origin, we're going to go out on the x prime axis approximately 2.4. So these are in terms of x prime, y prime coordinates. So this is the point 2.40. And going in our other direction gives us the point, say, negative 2.40. And our b, the distance on the minor axis from the origin, up 1.2. So going up approximately 1.2 along the y prime axis, giving us the point 0, 1.2, and the other direction, 1.2, giving us the point 0 and negative 1.2. Okay, and the only thing left is to connect the dots. So kind of sketching in our ellipse, and there we have the rotated form of our conic. Thank you very much.